Okay, so let's get started. Given two terms of a geometric sequence, find the first, third, and fourth. So let's write this out. So we do not have our first term, so we put a blank there. And our second term is 202. Our third term is we do not know. Fourth term, we do not know. And fifth term is 25.25. Now let's see how many times. So let's see what we have to multiply by to get 25.2 times, and let's see how many times. So one time, two times, and three times. So we can write this as 25.25 is equal to 202 times r times r times r. R is our common ratio. So we get 25.25 is equal to 202 times r to the third. Now we can divide both sides by 202. We get 25.25 divided by 202, so that's r to the third. And now we get 0.125 is equal to r to the third. And we get r is equal to 0.5, or 1 over 2. So now our first term, instead of going we multiplied by. So let's see. To find our first term, we can just say that instead of dividing by 2 or multiplying by 1/2, we're going to multiply by 2. So our first term will be 404. Our second our second term is 202, so we multiply 202 by 1/2 to get 101. That's our third term. Now our fourth term will be 101 multiplied by 1/2, which will be, let's see, 50.5. So now we have all our terms. And we already know the common ratio, which is 1/2, so we can just plug it in here. Now to find the nth term, we use this formula right here, or the nth term is just a formula we use to find any number in this sequence. So to find the nth term of a geometric sequence, we use the formula a of n is equal to the ace of first times r raised to the power of n minus 1. So our ace of n, let's in this case take the, let's see, maybe just we take the second term. So let's see, ace of 2 is equal to ace of first. So ace of first is 404 because that's our first term, times r, which is our rate. And now if we plug in our 2 right here, 2 minus 1, we should get the second term right here. So we get 404 times 1/2 raised to the power of 1. So we get 202, meaning our equation for our nth term is ace of n is equal to 404 times 1/2 raised to the power of n minus 1. Okay, let me minimize that. Okay, to find the 10th term, we do the exact same thing I did here, but instead of a 2, I plug in a 10 because we're finding the 10th term. So ace of 10th is equal to ace of first, which is 404, times 1/2, which is our common ratio. And then we plug in 10 instead of the 2 I plugged in here because we're finding the 10th term. So 10 minus 1, meaning 404 times 1/2 raised to the power of 9. So let's see what 1/2 raised to the power of 9 is. So, oh wow, okay. So it's 404 times 1 over 512. So our answer will be 4. Answer is 101 over 128 as a fraction, or we can put 0.789, and this is approximated. So let me just put the exact answer instead of the, this. So 101 over 128. Now to find the 46th term, we did the exact same thing we did here, but we plug in 46 instead of the 10. So we do a's of 46 is equal to 404 times 1/2 46 minus 1. So we get 404 1/2 raised to the power of 45. So 1/2 raised to the power of 45 is a very, very small number. So I'm just going to plug this into my calculator and get my answer. So okay, so our answer is a really big decimal. So let's see. Okay, so give me a second to plug this in. Okay, so it took me a little time because my calculator gave me an answer in scientific notation, but that is what this right here is equal to. So that's our 46th term. Okay, so next question says determine the partial sum from term 4 through 10. Okay, so to determine the partial sum, we use the formula S of n is equal to a's of 1 times 1 minus r over r raised to the power of n over 1 minus r. Okay, so our a's of 1 is 404. So S of n, right? So we're finding the partial sum from term 4 through term 6. Okay, so easy way to do this is what we do to find like how many terms there are is we do 10 minus 4 plus 1. So we have 7 terms. So S of 7 is equal to a's of 1, which is 404, times 1 minus r, which is 1/2 raised to the power of 7 raised to the power of 7 all over 1 minus 1/2. Okay, so let me just plug that into my calculator. So we get, let's see, 1 minus 1/2 raised to the power of 7, 1 minus 1/2. Okay, so 404 multiplied by, and our sum comes out to be, this comes out to be 801.687. That's our partial sum. Okay, now let's find the infinite sum, if possible. Okay, so the infinite sum of a sequence is only possible if the absolute value of our common ratio is less than 1. So in this case, the absolute value of our common ratio right here will be less than 1 because 1/2 absolute value is just 1/2 this. So we can find our infinite sum. So the formula to find our infinite sum is S of n is equal to a1 over 1 minus r. So s of infinity, because, well, you're finding the infinite sum, is a1, which is 404 over 1 minus 1 half, meaning our infinite sum will be 404 divided by 1 half, or in other terms, 404 multiplied by 2, which is 808. And that will be our infinite sum. Okay, so the next question says, explain why the sequence does or does not have an infinite sum by deductive math reasoning. So I had to download a calculator app for this to actually show you what I mean. So explain why the sequence does or does not. So we know that it absolutely does have an infinite sum because we just found the infinite sum, because the absolute value of r is less than 1. Now, have you ever wondered why the absolute value of r has to be less than 1 for an infinite sum to even exist? That's because, let's look at the formula again. So a formula is S of n is equal to a of 1 over 1 minus r, right? So if our infinite, okay, so let's say that's our infinite ratio formula. Now let's look at our, let's say, if we're finding the sum of some outrageous number, let's say like 5 billion, 6 million, or something like that, right? So we'll plug it into this formula right here. So if you plug it in, so let's say s of 6, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 8, 9 is equal to what should come out is 808. And I'll tell you the reason in just a second after I prove that it's 808. So let me just plug this into my calculator. So ace of 1, we already know that's 404. And then 1 minus r, which is 1 half, to the n, which is this big number right here. So I'm not going to bother to write it down here, but I will do it in my calculator. And then 1 minus 1 half, right? So let's see. Let's do, let's go over, let's move this over here. Okay, so let's see. 1 minus 1 half, which has been raised to the power of 6, 0, 0, 0, 0, 0, 0, 0, 0, 0, 8, 9, and let's just add some more numbers just for the fun of it. And that gives us 1. You see how the answer came out to be 1? Now, why do you think that's true? So let's take a small number and figure out why it's true. So 404, okay, so let me just first prove that the sum comes out to be 808. So 1 over 1 minus 1 half, which is just 1 over 1 half, which is just 404 multiplied by 2, which comes out to be 808. Now, infinite sum and the sum of outrageously large amount of terms comes out to be 808. Now, why does that appear to be true? Because so the formula is a of 1 times 1 minus our rate raised to the power of n. Now, if our rate has for our infinite sum to be true, it has to be less than the absolute value of 1. Now, why does that matter? Because if it's 1, let's say if our rate's 1/2, which is true in this case, if we raise it to the power of anything, it will always be less than 1, meaning our values will not exceed 1. So what I'm saying is that 1/2 raised to the power of 2 is just 1/4. Now 1/2 raised to the power of this number of like 6 million or 8 million or anything will be less than 1, meaning 1 minus r to the n will always come out to be less than 1 and will increasingly go closer and closer to 0. Now, if it goes closer and closer to 0, what in the end should happen is that we should get 1 on the top. And if we get 1 on the top and our rate on the bottom is still a fraction, meaning we can actually determine this right here, because we'll always get 1 on the top. So you see how this right here simplifies out to 1 if we plug in a very large number. So if it simplifies out to 1, ace of 1 times 1 is just ace of 1 over 1 minus r, meaning we can get our infinite sum. And that's